which is just the beginning of this day. Of course, there are still 2 free slots for demo jam. So if you have some idea for something to demo, just go to the Norm after this session and hand over him paper with title of your demo and your name. And now the Abel will tell you something about powerful patterns in XSLT 3.0.
Thank you. Somebody said that this is kind of the warm-up for Michael Kay's talk later about XSLT 4. So we start with the basic stuff here, patterns.
Abel, is your mic on?
He said it was on.
I can hear you. It's not. Oh, then it's on.
Can you make me on? Can you make me on?
We can try the different one. Just we will use the different one. Just take it out.
All right.
It is on.
Yeah, I know my voice is gone. Come on.
Is it better now? Just try to say something.
Say something. All right. So XSLT is, well, a language that really evolves around patterns. The moment you start writing an XSLT style sheet, you basically can't really do anything without starting to write your patterns, and that is the basis of the declarative nature of XSLT. What we're going to talk about here is about the things that have improved in XSLT 3. A lot of these things kind of stood in the shades or shadows of other talks, and I thought, you know, let's collect them in one talk and mention what all has been gotten new in XSLT 3. Unfortunately, that was a very long list, and if you're really interested in the details or in more of this, check my paper. In this talk, I will zoom in on a few of the more important changes. 2 questions. 1, who in this room has never done anything in XSLT? Don't be scared. I know you didn't. Second question. I have put a mistake somewhere in one of the code samples, and a little bit later on in the talk, in the slides, I will ask you to, well, tell me what that mistake is, and maybe you can even tell me why that is a mistake. Now, I hope that to come from some of the, you know, people that use day-to-day XSLT formatting, programming. So what actually is a pattern? You can look at it in various ways. A pattern is like a filter for nodes. If it's true, then the template is executed. If it's false, the template is ignored. Another way to look at it is that it's a simplified XPath syntax with only the forward access. And if you look it up in the spec, it actually says it is short for the expression root, the current node, //p, where p is the pattern. Now, there's a little bit more to it than only that, but that is the official definition of what a pattern really is. This gives it a big set of nodes from your whole document, and the processor then has to find out whether the current node is in that set. Now, that would be very, very slow, so the forward-only syntax of patterns works actually in the other direction, from right to left, from the point of view from a processor. And as if the processor starts on the rightmost point of your pattern, it has a much quicker ability to determine whether or not the current node is the node that it looks after, whether or not it matches. I'm going a little bit fast here because last time I did not have enough with 30 minutes. So let's have a little example. Since everybody here has been working with XSLT except 1 or 2, this should be a very simple example. We have a bit of input data, some items with a price, beer and pizza, and we want to get a nicely formatted list of what somebody has been billed for. So the pattern here. You knew this, right? This is no surprise to anybody. Okay, nobody speaks up, so that's the pattern, and that's the other pattern. This is just how it worked in XSLT1, in XSLT2, and in XSLT3. Nothing new there. Now, let's see what's actually new in XSLT3. We made one very big design decision while we were working on the standard, and we came with applying patterns, well, actually applying templates to non-nodes. And to match over such non-nodes, atomic items, anything else, functions, maps, we came up with the idea of predicate patterns. A predicate pattern is basically a predicate that says the thing that I'm testing is that, well, what I want this template to be executed for. It always starts with a dot, and then a bunch of predicates. Other than the first dot, it works exactly like any other XPath expression. Another change, it seems very minor, but it is that errors in patterns cannot be raised anymore. In XSLT2, they had, they could raise an error or they could be ignored, it was an option. And in XSLT3, whenever there's an error, it is ignored. And you see here in that example with the dot key equals 42, that is a way of matching against a map item that is at the same time the current item. Dot is the current item, it's a map. You can use the parentheses key, and you test whether or not it is number 42. But in a lot of cases, the current item won't be a map at all, so there will be an error. You won't get this error, it will simply ignore that and continue. The other major new thing is that in XSLT2 we had essentially only the child access that you could use. Well, of course you had a // but the second slash in that and then the path after that got expanded into the child access. So if you use a predicate on that, you could only count on the child access. Now in XSLT3 that's gone, and you can now also use the descendant access, descendant or self access. We can even use the namespace access, the self access, and we will see in a short while how that can be useful. But specifically the descendant access, of course, allows you to count over the whole descendant access instead of only the child access that you could do in 2.0. On the top level of expressions, you can now use accept and intersect. They basically mean the same as in XPath. A bunch of functions that you can use on the top level. Inside a predicate, you can use any function. You probably knew that. But on the top level, you can use the doc function, which basically says the thing that I'm testing over, does it belong to that document? Element with ID is just to complement the ID function. And the root function helps with matching over nodes that are not rooted in a document node. You can use variable references. Suppose you have this relatively long XPath, and you have to repeat it over and over. You can just create a global variable reference and repeat that variable reference in your pattern. That way it can become quite a bit more readable. An alternative that you could also use nowadays is what's called shadow attributes, but that's another topic for another talk. Comments in patterns, for some reason that was not allowed in 2.0, now it is. And parenthesized patterns and paths. We will zoom in on that later. What else is new? Quickly, streamable patterns. A pattern itself is not streamable, but it has to abide certain rules to make the template that it belongs to streamable. Explicit mode declarations allows you to have more control over what a certain mode does when, for instance, there's a non-match or whether there's a duplicate match. Initial match selection, when you start your processor with applied template invocation, you used to only be able to give it a document node. Now you can give it any sequence of items or a bunch of documents, whatever you like. And the whole syntax is more aligned with XPath now. Previously, you could write key, but you could not write fn key if fn was bound to the function namespace. That is alleviated, is the word. You can write union instead of just a slash if that's your thing. And E-qualified names, they can, it's like the whole namespace inside a name instead of just a prefix. You might say, like, why would you ever want that? Well, the only use case I can think of, but be free to come up with something new, is for auto-generated paths. So if you dump a path to a certain node with the fn path function, then you can use that path directly back as a pattern. Let's zoom in on those predicate patterns a little bit more. This is a bunch of templates. The first one is the initial template. It's also a 3.0 function feature. It means that's where we start. It applies data on the lines of data.txt, and it goes over all these lines. In the second template, the only thing it's doing is checking for whether or not it is an XS string. Everything is a string. They're like just the lines of the text. Then it tokenizes that. Basically, this is like CSV data. You see a little bit of an example on the top right. When it's castable as an int, we are interested in that. Sorry, I say that wrong. When it's not castable as an int, that seems to make a little bit more sense. Then we have beer or pizza, and when it starts with a euro sign, then we have the price and we want to output price. What you're seeing here is a simplified example from what's actually also in the specification. It's like a CSV worked out example that also uses templates, predicate patterns, and applies over them. The reason that this works, by the way, is that the priority of the templates is the one that comes last in the list. This could be the output, a beer for €3.14. I hope it's cheaper here in Prague. Okay, you've seen a few code pieces, hopefully long enough for you to have it sink in that I made a big mistake. Anyone? Anybody?
Your first here example matched on slash that had the variable that never, it wasn't a tree, it was elements five.
So see if that's correct. So what Norm was saying is that the first example on beer was not matching on a tree that was rooted in a document node. Is that what you said? Yeah. You all saw that, right? So, yeah, that seems about right. What we have there is a variable, bill, which is nothing more than a sequence of elements. There's no root document node. It's not a typical document that is rooted where each item comes from the slash. So what I'm doing here, / item, will never, ever match anything because there is no document root. Wrong. Why? Well, we know that now. You may want to know how to fix that, right? I forgot that part. Remove //. And in fact, when you find yourself starting an expression with //, you're probably not doing it for the right reasons. The only reason I can think of that you should start a pattern with // is when you really only want to match things that have a document node at its root. Otherwise, remove the / and you have the same expression. For starting with // middle slashes is a little bit different. How am I with time? Good, because I'm halfway. Perfect. Let's look at some subtleties. We already saw the // item. So let's zoom in on that parentless thing. So if you have a variable and you match, or you apply templates over that variable, it's quite common that that variable is not rooted in a document node. It doesn't have to be. You can actually root it in a document node. But when you don't, the differences between nodes that are rooted in a document node and are not are kind of subtle. So let's go over these one by one. So we saw / item. It does not match parentless nodes, and the / is basically redundant. If you remove it, the processor will allow you that only item can be matched against a parentless element. Descendant item, it does match parentless item, but it would not work in the previous example that we saw because it has to be a descendant, and the top nodes in that list of items, the sequence of items, they did not have a parent. Descendant or self will match any item because it also matches over self. Child item or item, they work because the processor, according to its specification, also matches top. It does not have to be a child to work as a child. Surprising, but that's how it works. Root / item, root always goes to the root of the current node, which would be item. In our example, this would not have helped us because it would match the item under root. Self item, I think, since the self access is allowed, I find that kind of the most clear expression that tells you you don't have to think of all the exceptions on the child access or the / or the descendant access. Self item matches any item, whether it's a root node or whether it's under a document node or not. Also, the processor doesn't have to track back. Self is only a test on the current node. It can be handy with performance. Some other subtleties. Let's try to match a single node. Basically, any node. Would they all work, you think, after what you've heard so far? Any node, this? The first one, right? Node in XPath. Yeah, you think it works? Almost. The reason that node doesn't match any node has something to do with backwards compatibility. I can't fathom why node, which means literally any node, does not match any node. But it is what it is in patterns. Descendant node, same story as earlier. It has to be under other nodes. Descendant access never matches attributes, doc, or namespace nodes. It's the same in Exelt, actually. Child node, same as node. Self node. See, self again, that's the easier one. You just add self in front of it, and it does match any node. It does match an attribute and a namespace node as well, or the document node. And the last one, why doesn't it match anybody? I didn't scare you off, right? I mean, I understand it's very quiet, but... Sorry, come again? Didn't we earlier see that there was not always a root document node? Oh, okay. So the /, but you're on to something. I mean, that's... Yes, but no. / does not always match. It only matches when there is a document root. So when you have a variable that contains a bunch of elements or attributes or whatever, or you do some micro-pipelining in your style sheet, / does not match. It actually gives an error. The error will be something like, cannot find the document node. Now, why it never matches is that we now have the situation, if there is a document node, it doesn't match. So probably the programmer wanted to match something that's not doesn't have a document node. But when there is not a document node, it throws an error. So what we are writing is not really what is going to work here.
That's a new one on me.
Sorry?
That's a new one on me.
I don't know if we have a test of this in the test set. Actually, I forgot to put the solution to this one in the slides, so you have to read the paper after all. Sorry. We saw a quick list earlier of what was possible with the new syntax. Put them all together and you get quite a vast list of new possibilities. One of my personal favorites is the except. I quite often have, like, I want to match everything except certain nodes. And I can make that explicit now. In XSLT 2, there were other ways to achieve the same, but this is way more efficient. Intersect, I struggled with coming up with a good example that really matches a use case. Maybe during the questions later, somebody can tell me why, I mean, in patterns, what intersect can be used for. This is just an example how it can be written. Counting the descendant axis, using element with ID for documents that, well, have elements with that ID. Element with ID, by the way, is a little bit peculiar because the current node must match the node with that ID, but the function element with ID takes all the elements with IDs from your whole document. So I hope your processor kind of does not try to do that again and again, but caches that. An example of using descendant or self, here you see it with the root function in the beginning. By using descendant or self, it also matches on root itself, if that is line. The example with a variable, long XPath or pattern, I just mean put that in a variable with your very complex XPath and match over that. It's as simple as that. So what the processor thinks is the other way around. It kind of checks whether or not the current node that you're testing is also in the same set as that variable. The map key example we saw earlier already. It's how it works. So last but not least, let's zoom in on this parentheses things. Why is that so powerful? Why is it so special? Well, when we came up with the idea of parentheses in patterns, I believe it was mainly to allow parentheses around the outer expression. So the whole pattern in parentheses, and you could add a predicate to it. But the way the syntax is written in the specification, it allows you to put those parentheses on every part of the, either on a step or around the whole expression. And within each step, you can use a complete pattern again. So what I'm doing here is, suppose I have a document, HTML document, and I want to find the first P that does not have any P before it. Now, there are ways to code that with predicates, but it's actually quite difficult because of the anchoring on the div. But using div star except P, or even // star / P or something, and then /P, you force that anything that comes between div and P is not a P. So you're guaranteed to have the first one. Having the OR expression, it's not really an OR expression, but para union P essentially means I want either a para or a P. Okay, close your ears. Sorry about that. The third one here, div star /star, it's the depth expression. So maybe you want to have the P on either the depth 2 or 3 or 4 children. That way you can be explicit about it and you don't have to do very difficult counting on the ancestor axis. Well, you can mix different axes if you want. You can go as high as you please within those sub-expressions. Those are step expressions in parentheses. These are the whole expression in parentheses, which then can still be followed by another step. The first one, whether or not it's in document A or document B. Second one, I think that one reads easy from left to right, right? Nodes, I want every node except para p or section. And the last one, a little bit tricky, because here I put the descendant author inside parents. Now, if I don't put descendant author inside parents, I get every fourth author that's on the descendant axis. If I put them in pairs, I get it counts all the descendants that it can find in the document, and then it takes the fourth, which will only ever match one node, the very first, that is the fourth descendant. I see Michael K. frowning, so maybe I say something wrong here. We'll see that later.
Think hard about some of these.
Now, even if you don't follow all these expressions right now, I'm basically showing them so to give you an idea of what you could accomplish, and by using intersect, except, or the parents with the or in the middle, it makes it a bit easier to read your expressions than when you have predicate upon predicate upon predicate. Well, with power comes great responsibility. There are things you shouldn't do. These are examples of what you shouldn't do. And in fact, no processor in existence does these well. Basically, all of them, some try something, others just throw an error. But they're legal, so they should work. I call these disjunctive patterns because after diff, I go back to the root, the slash root here. So I go all the way to the beginning of the tree. I told you at the start of this talk a little bit that the processor can do this check in almost O1. So it does not have to really move away from the node. It only has to check the ancestor axis. But here, that's all out of the window. It has to go all the way to the root and then still check if there's somewhere in H3. And then if I do that right to left thingy that I mentioned earlier, suppose I have an H3, then I go to the left, find myself a root that is also at a root, and then that diff can actually appear anywhere in a document. So I have a document, somewhere there's a diff, and somewhere there's a relation between root and H3. Well, this took me about a minute to explain that very simple expression. I told you, don't do it. Just, it's possible, and you can do some very incredible things with these to, well, piss off your coworkers, I guess. If you rewrite these in a normal predicate fashion, it would be something like slash root slash h3 with, with a diff somewhere in between. From all these weird things, maybe the middle one is somewhat useful. There's a document called default XML, so the current node has to be in that document. And you have a variable that you've set to, let's say, a certain complex path that we were talking about earlier. So here you're saying the variable has to point to that document and it has the same path, and then you want the rule element. Maybe a use case is that when you have one specific document, you want to treat it differently than all the other documents that you're processing. Other than that, SOS help if you start writing these things. Yeah, that last one is a legal expression. Trust me. And if you go on a little bit, you can even make some ASCII art.
Thank you. So anyone has some question? So the first norm and then...
Thanks. That was fabulous, Abel. That was a lot of fun. Can you go back one slide for me, please?
Only one?
Only one. I just want, as a point of clarification, you have slash root there. You meant slash root open paren, close paren, correct? You meant that in that first example for that to be the root.
Wait, which are we talking about?
The very first one.
Right?
The very, very first one. You don't mean slash root. You don't mean the equivalent of slash child : root. You mean the root function there, or am I misunderstanding?
No, yeah, that was a poor choice. I should have said something like slash start or slash note.
Okay, so I was misunderstanding. Thank
So
you.
yeah, it could be a single slash. That's also legal, but here I mean slash plus a starting node.
Yes, regards to the $config in your third example here, that is supposed to be a part of the pattern.
Yes.
Is there a special requirement for the data type of such a variable? Is it just a string that is evaluated as part of the pattern?
No, very good question. No, all those patterns that you've seen, except for the predicate patterns, they all work on nodes. The data type of your variable, your global variable, needs to be also of a node type. And the set of nodes that you're matching over with applied templates, it will only match if that variable that you have is a reference to the same node as the one that you're applying over. So if you would make a copy of a node, it doesn't work. They have to be rooted in the same element or document.
Food for thought.
Yeah. A more elaborate example is, again, in the paper, where you can see how that is worked out.
There's one you left out, Abel, which I find very useful, or I have found useful, and that's a bare variable reference, just $X. And the way I've used that is with Office documents. If you want to match something that's a following sibling of a footnote or something like that, it's very hard to write a pattern, at least an efficient pattern that does it. So you bind a global variable to all the preceding siblings of footnotes.
Yes.
And then you have a rule that just matches that global variable. And that's quite handy when evaluating the pattern would otherwise be very expensive.
Well, that is exactly where it is useful. Because
Yeah, you haven't got one that's a bare variable reference on its own. You've always got the /foo or something.
Yeah, you're
you
right.
can just use the variable as its own, on its own.
No, you're right. So what Michael K. was saying is that using a variable reference does not require you to add a path. You can, but you don't have to. And if you don't add that path, it has to match whatever that variable is referring to.
And the last question.
The previous slide, you explained something that I don't understand. No, sorry, subsequent probably. Power of parentheses. You said that div asterisk except p/p will match the first p, but I don't understand that. I would say it will match the first child of anything but a p. Is that, maybe I don't understand the notation.
The first one, right?
Yes.
Yeah, so the way it is written, it's meant as an example. You could expand it, of course. You have a div, and it's followed by any node. Well, sorry, any element.
It includes any element?
No, after, like as a child of the div, there is any element, but not a p. And after that, not p element, comes a p.
Is that what this means?
That is what that means, yes.
Okay.
Sorry. As a child, yeah. So the grandchild is a p, the first child is a not p.
Yes. Well, now I understand, because now it matches what I would think it matches. Thank you.
Okay.
Okay, thank you very much again.